Hello, everybody, and welcome to Ask the CEO. Today, I'd like to introduce a very special guest. He is the Director of Advanced Technology at Rockwell Automation. It is my pleasure to introduce Kyle Crum. Welcome, Kyle.
Thanks for having me. Really flattered to be invited. Ask the CEO, but I guess you're just gonna have to deal with a technologist today.
Well, actually, this is a prediction for the future. We're talking to a future CEO.
Yeah. Oh well, gosh, that'd be. I'm blushing, but maybe the CTO. We'll see.
All right, excellent. So, Kyle, I'm really excited to be talking to you today. Rockwell Automation just released their ninth annual State of Smart Manufacturing report. So I'm really excited to be talking to you today about that. But first and foremost, what is smart manufacturing?
Oh my gosh, that's an incredibly good question, Abraham. So when we think of smart, we think about a device that's broadly Ethernet connected. Something that can declare itself, something that can state what it does, and become part of a connected system as a whole, right? Why is the internet so interesting and compelling? Is because all of these systems are interconnected, right? And the thing that made that happen was the standard of Ethernet. Things can declare itself, and there's this internet protocol, and all of these different and diverse devices can speak to each other. Um, Networked control systems have been networked for a really long time. But as we see this convergence of IT and OT together, so information technology, what we usually use for computers, how we're talking today, and OT, operational technology, as those lines begin to blur, we see more and more Ethernet capability and other types of network capability. And so that's loosely what we think of when we think of smart devices, devices that can participate in that networked connectivity.
Great. And then now that's been brought to the manufacturing world.
Yeah, our devices have been on networks since the arguably the 80s, the 70s and 80s and 90s. And in fact, we had to invent a whole new discipline because as we became networked, we had to understand how to ensure dependability and safety. And so the field of functional safety had to be invented because the failure mechanisms of network devices is somewhat unique. And so we had to come up with a whole new area of science. Um, so we've been networked for a long time, but as that progresses, as we see the OT, and it's been mature in real time for a very long time, as we see that IT world start to connect in, yeah, we're starting to become, we call it the IIoT, the Industrial Internet of Things, but really it's smart manufacturing.
Great. So talking about, just the evolution of manufacturing technology, what are some of the challenges manufacturers face in today's day and age?
You know, um, I talked a bunch about technology for the past like few minutes. Interestingly enough, when you read the report that we just issued, that Rockwell just issued, manufacturers are really interested and focused on talent. Um, the technology, so what makes a manufacturer efficient, right, is the people, the processes, and the technology, all those three things together. You can have all the great technology you want, but if you don't have the people that can use it to accelerate the actual work, you're not going to get from here to there. So the report specifies, and what we've seen when we interact with our customers and other people, it's the talent. It's the talent that can take these new technologies and apply them to the work.
I love what you're saying. This is a fear that a lot of people have is that, robots are going to come and take their jobs away. And maybe to some extent, yes, but not, as a whole. And in fact, whenever I give a presentation about the trends in AI and technology, it's always inevitable somebody's going to come over to me and ask me that question, what's going to happen to our jobs in the future? And it's so refreshing to hear a company like Rockwell Automation, where, automation is its middle name, basically, and their focus is on people. I mean, they put people first.
Yeah, when we think about technology, we think about the use case for the person, right? Getting it done. In the survey, it states that we found that about 95% of the manufacturers surveyed said that they were going to maintain or increase their workforce as a result of technology adoption. What's going to change is the nature of people's work. And we actually saw this in again, in the 80s and 70s with the introduction of Excel. So there's a thing called Javin's paradox. And not to get too technical, but when you make a commodity cheaper, the demand of that commodity goes up. So if you read Wall Street Journal articles and things from the 70s and 80s when we introduced Excel, there were going to be no more bookkeepers, right? We were going to devastate an entire industry. What we saw was that because the access to bookkeeping tools became a commodity, became cheaper, there was an explosion in the use of those things. Financial analysis became, extremely prevalent. So the number of people involved in that activity actually increased dramatically. Javin's paradox is at work in automation as well, right? As these engineering tools become more available, right, and easier to use through generative AI and through all these other tools, right? What we're going to see and what we are seeing is that we need more and more of them. Now, the type of skill set is slightly different, right? We don't need a bookkeeper like we had a bookkeeper in 1965. That financial analyst is doing a different thing. They're applying cognitive behaviors to their cognitive behaviors in the sense that they're doing problem solving. They're not just recording the bookkeeping. They're doing analysis to determine future things. That's the same transition we're going through in automation. I don't want that repetitive same thing. The technology is liberating the individual from that repetitive, boring task, and I'm asking them to do problem solving. That's that skill set crisis, and not really a crisis, the transition we're going through.
Talking about the crisis and, like you mentioned, the transitions that we're going through, among many other challenges in today's day and age, how is Rockwell Automation helping manufacturers survive and thrive in today's difficult operating climate?
Yeah, there's a bunch of different dimensions. Let's just take like sustainability as one example. Variable frequency drives, the thing that we make that makes motors spin. In the end, let's take a step back. In the end, manufacturers don't make money until physics happens. A pump has to turn on, a heater has to heat, a conveyor belt has to move. All these other things are window dressing until physics happens. Something transforms from one thing to another. One of the devices we design and we offer are variable frequency drives. These are the things that make motors spin. Well, if you use a pump on a throttling valve, right, you're wasting an enormous amount of energy. So a throttling valve is just you kind of crack the valve open a little bit to change the pressure of the water coming out of like a pump. Instead, if you use a variable frequency drive, you only put in the energy you need. So we are helping manufacturers through these difficult times. One of the issues that's cited in the report is energy consumption. And we've all seen energy inflation, especially with the conflict in Europe, causing those energies to spike. These devices help manufacturers greatly reduce their energy usage. On top of that, we see the application of optimization routines driven by AI and other types of tools, helping people make good decisions at the top, at the top level. Should I increase manufacturing? Should I slow down over here? It's a really dynamic time. And so our industry needs to arm itself with knowledge and understanding how to make those good decisions and apply tools to help those people make good decisions when they need them.
One of the more common aspects of manufacturing that's more widely known is predictive maintenance. Where you don't have to go and waste parts by replacing them on a schedule. Rather, you have the part itself tell you when it needs to be replaced.
Yeah, I mean, this goes all the way back to work done actually on aircraft, right? It's very expensive to take an aircraft out of service to go do a periodic inspection of a wing, let's just say. Well, if I understand what actual service that aircraft went into, I can predict that failure much more accurately and only take that aircraft out of service when it's needed. Those same techniques that were developed in aircraft are dramatically impacting uptime for factories.
So now all these technologies, all these processes require data. One interesting statistic I saw mentioned in Rockwell Automation's ninth annual State of Smart Manufacturing report is that only 44% of data is being used effectively. And, furthermore, it's broken down by size of company where, if you dig deeper, the smaller the company, the less efficient they are in using their data.
Yeah, the manufacturing systems create an enormous amount of time sequence data, right? Like, let's go back to that example with a variable frequency drive. We're talking about gigabytes and gigabytes of data a day. If you were down to the microsecond or the millisecond, let's just say, um, being able to move that data around is different in the manufacturing space than it is in the IT space. So, if we're on human timescales, right, the number of clicks on a web page, the number of views of a video, let's just say. Obviously, I hope this video gets millions and millions of views. Well, that data isn't high frequency. So I can move that data, I can do analysis on that data, I can use relatively heavy tools. Well, in the manufacturing world, it's completely different. A drive might make gigabytes of data, but it's not practical to move that data away from the edge because I would need massive amounts of data collection, terabytes after terabytes of storage. So edge compute is the thing that we're really interested in, and I personally think is going to continue to revolutionize our industry. AI tools that use much, much less memory and overhead that are appropriate for our industry are still being developed. And so I think you're going to see waves of innovation as we can leverage more and more of that. I saw in the report as well, even large manufacturers are only using 51% of their data. The runway is really large, and I'm particularly excited about that edge, that high frequency data that's really hard to get our hands on, but has really interesting outcomes when we can get it.
Now, that is a great segue into cybersecurity, because, with all this amount of data out there and all these connected devices, that can leave potentials for vulnerabilities. And in fact, IoT has a reputation of being manufactured for more for convenience rather than security. Where do you see that going?
Avraham, I'm glad you brought it up. Yeah, IoT is different than IIoT. The things that industrial automation controls are cyber physical systems that are important to our daily lives. The water we drink, the electricity flowing into our homes. We depend on these systems to keep us alive.
Yeah.
And if they are non-deterministic, if they're hacked, people can get hurt. People operating them can get hurt. And some of these systems we're talking billion-dollar assets. And so as we see the continued blurring of IT and OT networks, meaning Ethernet is pervasive throughout all these systems, we have to be mindful. So before IT and OT systems were connected, when you just had IT systems, the things that were at risk for cyber attack broadly was your finances and your reputation. If you had a hack, you either lost money or you lost information, data. With a physical connection, you're starting to put infrastructure at risk. And OT systems have much different requirements for real timeness and determinism. We have to know how they're going to operate. So that's one of the reasons why our customers like to work with people that know the manufacturing space, not just an IT vendor, to provide these types of services because they're just a little different. And being wrong has some serious consequences.
Yeah, indeed. Let's talk a little bit more about AI and the latest trends in smart manufacturing. So AI plays a big role in security as well, just in general, but especially manufacturing. And there's another type of AI that's come on the scene within the last year called generative AI. Now, when I think of generative AI, I think about ChatGPT writing essay reports for students and, things like that. The report mentions generative AI as being one of the top emerging technologies in smart manufacturing. Where do you see that fitting?
Well, number one, off the top, I want to thank you for differentiating and saying that generative AI is just one type of AI. It's important to remember that AI and machine learned AI, these are families of technologies. And generative AI as a whole isn't necessarily new. But with the advent of the transformer, the technique that they use for these large language models, we're seeing this, absolute explosion in their use. When it comes to manufacturing in particular, what I'm personally really excited about is speeding the development of code. So, manufacturing typically uses these IEC languages that are specific and domain specific to us, and there's very good reasons for that. Though we're starting to see other languages be used, primarily still the number one language being used is called ladder logic. Traditional large language models are not going to help you necessarily with ladder logic, but we have a huge library of those things that can be trained. And so what I'm really interested in and I'm really excited about is seeing the productivity gains that automation engineers are going to see as they leverage these co-pilots for ladder logic. And then for troubleshooting, there's been demonstrations and I've seen some early market emergence of large language models specific to automation that can allow you to troubleshoot ladder logic, to explain rung by rung what's happening to me. So that downtime that your factory's seeing and the engineer that wrote that code is long retired. There's
And
someone,
it was written in COBOL.
yeah, it was written in COBOL. Yeah, there's someone to help now. And help aid that engineer, that technician that it's 2 a.m. and I got to get this plant up. There's a system that goes through and helps you. And that goes back to our people focus. These tools, this technology has to be thought of and designed as an aid to the cognitive ability of people. It's decision support. That's what we're talking about. And as soon as a producer or an individual forgets that the technology isn't just for the technology's sake, we are here to support the people doing the work. That's when we see real value.
I love this. I preach that all the time, that technology is here to serve us. It's not going to enslave us. It's not going to take away our jobs. It's here to augment our skills and our capabilities and help us do what we need to do more efficiently.
If it's well designed and if we're thoughtful, I think when you take the eye off the ball, I completely agree. When you take your eye off that ball is when you start to see products that are not necessarily helpful.
Now, one last product that I wanted to talk about was wearables, because the report mentions that that's another emerging technology in the manufacturing space. When I think about wearables, I think about, smartwatch helps me count how many steps I take, every day, and heart rate and things like that. Where do wearables fit in manufacturing?
So this is an emerging topic, and there are lots of varied opinions. So take this with the grain of salt that this is Kyle's opinion. Um, what I really like is the concept of wearables and it merged with the idea of what's called spatial computing. Understand where the human is in relation to equipment. If I know who you are, if I know you're the plant manager or a maintenance technician or an operator, I know your persona, and I merge that with the state of the machine. The machine is in an upset condition. The machine is in standard production. The machine is down for maintenance. And then the third thing I put together is where you are, right? So our telephones, our watches, other wearable devices can provide that type of information. When I merge those three things together, I can start to present information to you that's relevant to your job. If you're the plant manager, I talk about throughput and OEE. I talk about things about the health of the plant as a whole. If you're that maintenance manager, hey, we're in an upset condition. This is the manual you need to be aware of. And by the way, here are the workers that are currently qualified for that, let's say, high voltage situation. I think we're going to see. I think we're going to see a continued growth in wearable VR and AR, but it's got to be people focused, and it needs to be in particular focused on things that need 3D. When people just put a PDF up in your field of vision, while that's interesting, not necessarily compelling because that's a 2D product. What I really like is when you need 3D volumetric type of engagements and use cases. We have a program we like to call hands-free. How do I keep the worker focused on the work and not holding a piece of paper or a clipboard? So auditory augmentation, visual
Heads up display.
up displays. I think we're going to see a lot more wearables, but we got to take that people first approach.
This is a really great in-depth discussion on the future of smart technology. Where do you see smart technology headed in manufacturing?
I see a bright future. Networked devices, like we talked about at the very beginning, right? We connect as more and more devices become connected, Abraham. We're going to see this ubiquity of compute. We're going to see compute out at the edge. We're going to see AI models that are more appropriate for small compute surfaces. And devices are going to get smarter and smarter and reconfigurable. And so really, a core trend we see is high mix, high volume. Manufacturers want to produce a lot size of one, but they don't want to slow down the manufacturing line. So the first one widget comes off, and then the very next widget might be a completely different thing. And as our devices become smarter and smarter and more agile and able to respond to changes instantaneously in the demand signals, that's really where we're headed, right? Is that autonomous system that helps the user through various, through variability. It's going to be fun. It's going to be really fun.
Looking forward to it. Kyle, do you have any parting words of wisdom that you'd like to share with the audience?
Oh gosh. Number one, read the report. It's really interesting. As a technologist and as somebody that works on this every day, I, right, though I'm steeped in it, find interesting things in the report every year, and this 9th edition is definitely another one of them. And then second, look for convergence of technologies and focus on the people, and then the people will focus on the work.
Kyle, thank you so much for sharing your time and your wisdom. I really enjoyed having you on the show.
Abraham, thanks for inviting me, and I look forward to talking to you in the future.